Welcome back to Graphing Polynomials, and this is part 2. So this is a shorter lesson just because we need to cover just one more method in graphing polynomials. This is the most common method that they're going to put on the exam just because it is quicker to graph. And they don't want to spend 15-20 minutes on one question just to graph a polynomial. So this is the most common one. By no means does it mean that they won't ask you other questions, but be prepared for this one especially and really understand it. Okay, so multiplicity of 0. This just means that how many times the particular number is a 0 for a given polynomial. So for example, in this function f of x, the 0, 3 has a multiplicity of 4 because that's the exponent that is attached to it. The 0, 5 has a multiplicity of 1 because there's an invisible 1 and that is the exponent of it. And then the 0, 8 here has a multiplicity of 2 because the power is 2. So the general rule is if the 0 has an even multiplicity, then that means the arms on either side of that 0, so let's say your 0 is 0 in this graph here, that means that either side will act like an even function where both of your end behaviors are going to point in the same direction. If the 0 has an odd multiplicity, then the arms on either side of the 0 will act like an odd function. So that means we have different end behaviors for odd functions, like this one. Also, how you are drawing your graph when it hits through the 0 is very important as well. So this one is when you have a multiplicity of 1. It should look like a linear graph going through the 0. So this is your 0 because that's where you hit the x-axis. And when you go through it, it looks like just a linear straight line because it has a multiplicity of 1. Now when you have an even multiplicity, then it has to look like a parabola. Okay, so if you have an even multiplicity, so let's just say at your 0, you have a multiplicity of 2, 4, 6, and so on. This is the general shape of it. Both of the arms are going to go in the same direction, either above or it could also be below, depending on where you are at with that graph. And now, lastly, for powers, multiplicities of 3, 5, 7, any odd number, and so on, it's going to look more like a cubic function, that it flattens out around 0. So let's just say that's your 0. You should always draw flattened out with your end behavior as opposites. So let's just try to do this with an example. So the 0, 1 has multiplicity of 2 because that's the power associated with it. And then the 0, negative 3 has multiplicity of 2 because of that power. So your first step is to draw the zeros. And that is going to be at 1 and negative 3. Step 2 is find the y-intercept. So in this case, we're going to look at f of 0. So we just plug in x equals 0 into our function. So that is 0 minus 1 squared multiplied by 0 plus 3 squared, which is 3 squared, 1 times 3 squared, and that's 9. So we're going to plot that as well. So 2, 4, 6, 8, 10, and I'm going to plot that right here. Step 3 is use multiplicity rules. So that's the stuff that I stated over here. Now, what we can also do is connect the points that we do have, because we already have the zeros and we have the multiplicity points, those zeros at the bottom here. So we can already see the pattern, because we don't need to come back down to the x-axis at all at any point, because we already have the 2 zeros. So by this pattern, it looks like I have to go up to reach my y-intercept and then come back down to reach my 0. So that's the shape that we have so far. Now we have to figure out, okay, what is the rest of this going to look like? What is the end behavior going to look like? Well, first of all, we have an even function because we have a squared here and a squared here. So we know that the two arms have to go in the same direction. Now looking at the specific zeros and their multiplicity, around 1, it needs to look like a quadratic because it has a multiplicity of 2. So just thinking of this one, I already have one arm. So to make it look like quadratic, the other arm has to go back up. And then that's it for that side. The 0 of -3 has a multiplicity of 2 as well. I already have one arm, and this arm is up. So then in order to make a parabola around that, I have to go back up. And then we are done with our graph there. So you can do the next one on your own and try it on your own. Try to follow the same steps. I know you might get a little confused around the multiplicity part, but just try it and then I can explain it to you afterwards. Okay, so here's the solution to the try it yourself. Your multiplicity is going to be 3 around -2 and 2 around 1. So I said it's going to look cubic looking around x equals 2, around that 0, and it's going to look quadratic looking because of the squared around the 0 of 1. So the first thing you're supposed to do is plot your zeros. Second thing is finding the y-intercept, which is -8. Remember, we're going to plug in x equals 0 to find that. Then the next step is probably just to follow the pattern with your y-intercept. So it looks like we had to go down to get to our y-intercept and then come back up. The next part is the most tricky part, and that is using your multiplicity rules to figure out the rest of the graph. So it did say that we have a cubic looking function around x equals -2, sorry, -2 there. And that means that I need to flat line it around my 0. And that because it is cubic, the arms have to go in opposite directions. Because if I go back down, then it looks like a parabola again, because I'll have a large hump like this. And that is not the case. And then for the other side, our 0 around 1, it needs to look like quadratic. So I already have the one arm and it is facing downward, so that means I have to make it even. It's an even function, so it has to look sort of the same. And then now I kind of like a small parabola here, and that's even. So both of the arms need to go in the same direction. Now overall, if you take a look, we have a negative coefficient, so we do need to go from increasing to decreasing, which is what we have. And if you look at the overall power of our polynomial, it is 5. It is an odd number. So that means our end behavior for this entire function, they have to be opposite. So they have opposite end behavior already, so we know that we did a good job, because on the left side, it's going towards positive infinity. On the very right side, it's going towards negative infinity. So that's opposite end behavior.